Okay, hello students. Today we are taking up another chapter, chapter number 4. So, chapter number 4, we have linear equations in two variables. You have already learned about linear equations. What is a linear equation? Okay, an equation in which the variable's highest power is 1. So, we call them as linear equation, right? So, for example, let's say I take up an equation like this: 2x plus 4 is equal to 0. This is an equation. We have a variable here. So, one side is equal to 0, left hand side and right hand side. So, there is an equation, there is an equal sign in between. So, here we have a variable also. Look at the variable. If we look at the variable, you can see that the highest power is 1, right? So, the exponent here is how much? Exponent is equal to 1. So this type of equation, we will call them as linear equation. And if I take up another example like this: 2x squared plus 3x plus 4 is equal to 0. Is this a linear equation? No, this is not a linear equation because look, we have variable x, but the highest power of the variable here is 2. The exponent for the variable here is 1, here is 2. So since 2 is the higher power, since 2 is the higher power, you cannot say that this is a linear equation. This will be something called quadratic equation, which you will learn in another chapter. But here it just doesn't say, the topic doesn't say the linear equations, right? It says linear equation in what? In two variables. It's linear equation in two variables. Here we have only one type of variable. The variable is what? The variable is x. So it's only one type, right? Okay, if I have another equation like this: 2x plus 3y is equal to 4. This is also an equation. But from the perspective of whether it's a linear or quadratic or cubic, you have to check the power of the exponents first, the power of the variables first. Look at the variable is x, and y, the power of x is 1, the power of y is 1. So this is a linear equation since the exponent is the highest power is 1. So in this linear equation, we have two variables also. We have two different types of variable, x and y. So we will call this type as this is this condition, this satisfy two conditions. It is a linear equation and it has two variables. So this type of equation is what fits the topic of this chapter. This is a linear equation in two variables. Okay, in order for you not to confuse yourself, let me put up another example, something that look like this: 2x plus 7xy is equal to 1. What about this type of equation? No, this is not a linear equation. Okay, there is two variables. Okay, we have x here and y here. We have two unknowns. This two variable part is satisfied, but this is not a linear equation. How so? Let's look. The power of x, the exponent for x here is 1. The exponent for x here is again 1, and y here is 1. But when we consider this part, the part where we have the 7xy, this 7xy. The 7, we are not going to consider it in order to calculate the exponent because this is not a variable. The exponent of x is 1, that of y is 1. The exponent of this combined term xy is 1 plus 1, so we will write it as 2. So here the highest power is 1 here. For these two together it is 2. So this has two variables, yes, but the highest power is not 1. The highest power is 2. If the highest power is 2, we will call this equation as quadratic equation. This is a quadratic equation. Since we have two variables, x and y, we will say that this is a quadratic equation in two variables, unlike the one you are going to learn in the other chapter called quadratic equation. We have two variables here and the highest power is 2. So this cannot be counted as a linear equation in two variables. Okay, I believe you know what is a linear equation in two variables, right? Okay, so once we know what a linear equation in two variables is, let's try to put a form like this: 2x plus 3y is equal to 4, x plus y is equal to 7. Okay, better start with the easier one. X minus y is equal to 1. Okay, so we have got two linear equations here. We have two variables in them also. We have x and y. Another type of linear equation, the basic type that you have learned in class 9, it looked like this, right? 2x plus 3 is equal to 0. We have only one variable. When we come to the solution, what is the meaning of solution? You already know the meaning of solution, right? Solution means the value of the variable that will satisfy the equation. So the variable here is x. The variable here is x. What value of x shall we put there? Shall we put in this left hand side in order to satisfy this whole equation? Okay, we can find out the value of x easily, right? So you just take the 3 to the other side. We will have 2x is equal to minus 3. And when we find out the value of x, we will have minus 3 by 2. So if I put the value of x as minus 3 by 2 here, then let's see what happened to the left hand side and to the right hand side. Left hand side, it will look like this: 2 into minus 3 by 2 plus 3 is equal to, so 2 and 2 got cancelled. We have got minus 3 plus 3, which is equal to 0. So when I put the value of x as minus 3 by 2 in the left hand side, this left hand side, and then we calculate the value, we are able to obtain that the left hand side is exactly equal to the right hand side, right? So this x is equal to minus 3 by 2. The value of x is equal to minus 3 by 2 that we are having here, that we have obtained. This is called as solution of the linear equation. If we have one variable in a linear equation, one equation is enough to solve it. Okay. In order to find out the solution of a linear equation, we need only one equation, so that if there is only one variable in the equation. But what we have? What if we have two variables? Like example here, twice x plus 3 is equal to 0. This is one equation, one variable. One equation is enough to solve a linear equation with one variable. But in case we have a linear equation with two variables in it, like the example of these two equations, we will need two equations. Okay, the same principle will apply if you have three variables. Let's say I have a linear equation like this: a plus b plus c is equal to 0, a plus b minus c is equal to 3 minus 3, 2a plus b plus c is equal to 7. So yeah, we have a linear equation. The variables are a, b, c, a, b, c, a, b, c. These are the unknowns. In order to solve what is the value of a, what is the value of b, what is the value of c, since there are three variables, we will need the three equations. So if we have two variables in a linear equation, you have to note this: we need two equations in order to solve it. Okay, so solving a linear equation. In order to solve a linear equation, we can apply so many methods. Okay, so first and the most basic one, this is the first and the most basic one is the graphical method. Second, we can have something called elimination method, and the third one we will have something called substitution, and there is also another one which is known as cross product method. Okay, we will learn this method one by one. But first of all, let's just focus on this method right here, graphical method. Okay. What we are going to do in graphical method is, we have two equations here: x minus y is equal to 1 and x plus y is equal to 7. We will draw the graph of both equations. We will draw the graph of x minus y is equal to 1, and we will draw the graph of x plus y is equal to 7. And then the solution, the value of x and y, means when I put the value of x and y here, it should satisfy this equation, and it should also satisfy this equation. So what is the value of x and y that satisfy both this equation? That value at that point, the two graphs will cut each other. Okay. So that point, we will take it as a solution. So in order to do that, let's focus. Let's do the graphical method by taking these two equations as an example. I believe you already are familiar with how to draw graphs from class 9, right? So here we have an equation: x minus y is equal to 1, in order to draw the graph of x minus y is equal to 1, you first need a table. So in order to draw the table, in order to make up the table, we need to find out the variable with respect to another variable. So let's find out y. Okay, it's always easier to find out y in most of the equations that you will be facing in the exercise. So let's find out y from this equation here. We have x minus y is equal to 1. If I want to find out y, then y goes to the other side, 1 comes to the left side. So when 1 comes to the left hand side, we will have x minus y. When y goes to the right hand side, we will have plus y. Reverse it, we will have y is equal to x minus 1. Okay, put up the table. We will write table 1 because we need to put up the table for the other equation also. We will have two tables, table 1 and 2. So table 1, let's write the value of x here. Let's write the value of y. You know that a graph is a line, right? Graph is a line. In order to draw a line, you need 2 points. So if I have a point here and a point here, then I just have to join them. So in order to draw up a graph, what you need is 2 points in a graph. So let's put the value of x as 1. So if I put the value of x as 1, let me draw it green. If x is equal to 1, how much is the value of y? You just put in the value here. We're going to have y is equal to x minus y. So 1 minus 1, so we have 0. Look, when x is equal to 1, y is equal to 0. Let's put there x is 1, y is 0. Okay, this one will be a point. Take another value of x. Okay, take another value of x, preferably 0, 0 is okay. So if x is equal to 0, what then? Let's put x as 0 here. So 0, if I put x as 0, then we are going to have y is equal to 0 minus 1, which will be minus 1, right? So we will put the 0 here, minus 1 here. When x is 0, y is minus 1. What are the points now? When you draw a graph, the graph in the plane that you are drawing the graph is called the Cartesian plane, and then the points, they are represented by x, y. X, y is called a coordinate. X is the x coordinate, y is the y coordinate, right? You have already learned this in class 9. So what is the value of x? What is the value of y? Combine them together, you are going to get a point. So yeah, when x is 1, y is 0. This is 1 point. You have to put like this, 1, 0. This is 1 point. And when x is 0, y is minus 1. 0, minus 1. This is another point. I already said that we just need 2 points in a Cartesian plane in order to draw a graph. So the points related to this particular equation, x minus y is equal to 1, is 1, 0 and 0, 1. So the points are the points 1, 0 and 0, minus 1. Okay, the table for the first equation is done. Let's come to the second equation. Okay, we have to put up the table for this equation also. So here, x plus y is equal to 7. Let's calculate y here also. Y is equal to 7 minus x. Let's take up values. We just have to write table number 2 here. X, y. So when x is 3, let's say. When x is 3, how much is y? When x is 3, y is how much? Y will be 4. Okay, if x is equal to 3, y is equal to how much? 4. Okay, you can reverse it, or you can take up one value. How do we make this value of y as 0? We can just put 7 here. 7 minus 7, we will obtain 0. So in order to obtain y as 0, we will just put when y is 0, how much is x? In order to obtain y as 0, we are supposed to put x as 7, right? So if x is equal to 7, y is equal to 7 minus 7, which is 0. Okay, now we have also got 2 points here. The 2 points are 3, 4, and 7, 0. So the points are 3, 4. This is one coordinate. What is the other? The other is 7, 0. Yeah, now we don't need the table anymore since we have already obtained the points. Look what the points associated with this first equation are. It's 1, 0, and 0 minus 1, right? So let me just write on the left hand side portion here. 1, 0, 0, minus 1. What about the other equation? The other equation, we have got 3, 4, 7, 0. Okay, so let's rub off the table and the whole calculation, because in order to draw the graph, we just need the points. So let's draw the graph. You need the axis first. This is the y-axis. This is the x-axis. Okay, here was the origin, right? And we have got the origin. This is the origin. So let's mark them equally. Here is 1, 1, 2, 3, 4, 5. I'm going to draw it properly when I'm going to draw it in the graph paper when it comes to solving questions from your textbook exercise. Okay. So what is the maximum value of x? The value of x are 1 here, 0 here, 3 here, and 7 here. So we have got 0, 1, 3, 7. 7 is the largest value of x. So you need to put off the point until 7. Okay, just 7. 1, 2, 3, 4, 5. Then we have 6, then 7. So 1, 2, 3, 4, 5, 6, 7. What about the value of y? The value of y is 0, minus 1, 4, 0. So we have got 0, minus 1, 4. That's it, right? 0, minus 1, and 4. So we need to put up one value on the negative side, minus 1. Let's put two of them, minus 2. And then we have got 1 here, 2 here, 3 here, and 4. So let's put in the values then. If I want to draw the graph of x minus y is equal to 1, we have got the 2 points, 1, 0, and 0, minus 1. We have already seen how we have obtained these 2 points, right? So 1, 0, 1, 0. Okay, when you put in the points, when you mark the points in the graph paper, what you have to understand is 1, 0. Do like this. This is the x coordinate, right? Go on the x-axis, 1 points. On the axis, go 1 points, and this is 0, right? So if there is 0, you don't have to raise up. Another example, if I have 3, 4, go 3 points on the x-axis. This is the y coordinate. So y coordinate is vertical. So if it is positive, you have to go up. If it is negative, you have to go down. So go 3 points on the x-axis and then 4 points up in the x-axis, up in the y-axis. So do like this. If I want to mark the 3, 4, I have to go 3 points to the x-axis, and then the 4 you have to go upwards vertically here until you reach 4. So here is your point. Here is your 3, 4. Okay. Okay. So and if I want to mark the point 1, 0, what you have to do is you have to go 1 point on the x-axis like this. 0 means you don't have to go up or down. You just have to raise the point here. So this point is 1, 0. One more example. Let's say I want to put up 0, minus 1. What about 0, minus 1? 0, minus 1, we have to write like this. 0, 0 means on the x-axis, you are not going anywhere. So 0, minus 1. On the x-axis, you are not going anywhere because the x-coordinate is 0. So you have to put your point here. Minus 1. If there is a negative sign, you have to go negative. That means downward direction in the y-axis. How much? 1. So here is your 0, minus 1. Okay. Once I believe you have already known how to mark the points in the graph already in class 9. I'm just revising them. Okay, once we know how to mark the points already, let's mark the points for this particular equation right here. X minus y is equal to 1. It's 1, 0, and 0, minus 1. 1, 0, where is it? 1, 0 is here. 1, you have to go on the x-axis, 1 point, and then there is 0. So here, let me mark it with a black point. So here is your 1, 0. What about the other one? What about the 0, minus 1? So 0, minus 1, what are we going to have? In the y-axis, in the x-axis, you are not going anywhere because it's 0. 1, 0 is already plotted, right? It's here. What about 0, minus 1? 0, minus 1 is on the x-axis, you are not going anywhere. On the y-axis, you have to go downward 1 point. So here is 0, minus 1. That's it. So this is 0, minus 1. I'm plotting it here with a black mark. This is 0, minus 1, and this is 1, 0. Okay, let's make it longer. Okay, here is your graph. Here is the graph for x minus y is equal to 1. Come to the next one. The next one is x plus y is equal to 7. We have the points 3, 4, and 7, 0. Where's 3, 4? 3, 4 is on the x-axis. You have to go 3 points. Go upwards. How many? How many points? Up to 4. Okay, so we have got the point here I'm going to mark it like this. Let's mark it with red. Okay, better do it green. So here, at this particular point, we went 3 points on the x-axis and 4 points on the y-axis. So here is your point. You will have no difficulty plotting this in case we have the graph paper. So let's rub this off. So here is your point. Here is your point of 3, 4. Okay, what about the other one? The other one is 7, 0. You have to go 7 points on the x-axis. If there is 0, you are not moving anywhere up or down, right? So you just have to stop here. This is 7, 0, this particular point. But this is 7, 0. Okay, now let's draw the graph for this particular equation x plus y is equal to 7. You just have to join them. Okay. Okay, now the question is the solution. The solution is the value of x and y which satisfy both equations. And if I draw it in the graph, we will get a particular point which belongs to both the graphs. What particular point belongs to both graphs? Look, what particular point belongs to both graphs? This graph, this point belongs to this graph only. This point belongs to this graph only. But what about this? This point where the two lines, the graphs of the two equations intersect. It belongs to this line also. It belongs to this line also, right? So at this point of intersection, the value of x and y that will satisfy these two equations right here. So what is this point of intersection? You have to determine. It is 3 here and 4 here. Okay, look, in order to determine this point, you have to look how much we have moved along the x-axis. Along the x-axis, we have moved 4 points. In the y direction, how much have we moved? We have moved 3 points. So x-axis is 4 points, y direction is x-axis is 4 points, y direction is 3 points. So we are going to write this point of intersection as 4, 3. So in 4, 3, this is the value of x, this is the value of y, right? So after we draw the graph, we will say the point of intersection is how much? The point of intersection is 4, 3. From this, you have to take out the value of x and y separately. This is the value of x. This is the value of y. Okay, let's see if I put the value of x as 4, y as 3. See if we are able to satisfy these two equations. If I put x as 4 and y is equal to 3. So we have got 4 minus 3 is equal to 1. Okay, correct. We are able to match the right-hand side. What about here? 4 plus 3. 4 plus 3, this is equal to 7. We are able to match the right-hand side again. This way, we will be able to solve two linear equations. Okay, two linear equations with two variables in it. We just have to find out the point of intersection. Now that we know how to solve two linear equation by plotting their graphs, now let's come to the conditions whether they will the two graphs will intersect, will not intersect, or will there be coincident. Okay, say we have two equations like this. A1x plus b1y is equal to c1. A2x plus b2y is equal to c2. I'm writing the coefficients of x and y, and along with the constant term, I'm writing them as a, b, c. Because we have two equations, I'm writing them separately as a1, b1, and c1. Okay, if I draw the graph for these two, there might be these three conditions. Okay, we have the x-axis and y-axis. There is possible three conditions possible. Number one, the two graphs will intersect. Okay, where they intersect depends on the coefficients a, b, c. Okay, if they intersect, how many solutions are there? There's only one solution. There is only one point which belongs to both the graphs. That means there is only a value of x and only a value of y, which you put in the equations, it will satisfy the equation itself. So this one, we will call it as graphs are intersecting. When the graphs are intersect, they intersect at one point. Since there is only one point, we will say this as unique solution. Okay, another possibility. Second possibility, the graphs look like this. The graphs are parallel. If the graphs are parallel, they are not intersecting anywhere. That means a point in this graph is not a point in the other graph. There are no common points between these two graphs if the two lines are parallel. which means the two equations that you are trying to solve, they will not have a solution. Okay. Example, if I take up x plus y is equal to 3 and another x plus y is equal to 4. Is it possible to solve these two equations? Is it possible that there is a value of x and y in which addition is 3 and addition is 4? Oh, that's not possible, right? Or another x plus y is equal to 3. I'm giving them as pair, okay? And 2x plus twice y is equal to 7. This one, we can reduce it a little bit. Can take the 2 as common factor. And x plus y will have 7 by 2. From this equation, we have x plus y as 3. From this equation, we have x plus y is equal to 7 by 2. Is it possible that there is a value of x and y which addition is 3 and also addition is 7 by 2? No, that's not possible. In that case, if you draw the graph of these two equations, these two types of equations, okay, we are going to get something like this. If not like this, you will get something like this. Something like this in which the two graphs are parallel, where the two graphs, they do not intersect at any point. So that one, if the graphs are parallel, if the graphs of two equations are parallel, we will call it as parallel graphs. Parallel graphs, they have no solution, so we will show it as, we will say, we will use the word inconsistent. And another possibility, if I have these two equations, x plus y is equal to 7, and I have another equation like this. Okay, there are two equations, but if I change this, I can change it like this, take out the 2 common factor, take the 2 to the other side, x plus y is equal to 14 divided by 2, so we get 7. These two equations are the same, right? That means if we are given equations of the form like this, x plus y equal to 7, 2x plus 2y is equal to 14, they represent the same equation. So when we draw the graph, we're going to get only one line, not two different lines, okay? We're going to get only one line. Let's say this is the graph of the first one. The other one, we are going to get like this also. Same, above. Okay. The red one is for the other and the black one is for the previous one. They will coincide. The two graphs, they will coincide. So if the two graphs are same, we will say they coincide, and we will say there is infinitely many solution. Okay. The condition that satisfy here will satisfy here also. If I take 3 plus 4 is equal to 7, if you put x as 3 and y is equal to 4 here, we will have 2 into 3 plus 4 into y, which 2 into 3 plus 2 into 4, we are going to have 6 plus 8, which is 14. Okay. So condition that satisfy here will also satisfy in the other question. So if the two graphs are the same, we will say we have infinitely many solution. And the word that we are going to use, the term that we are going to use is dependent. Okay, so we have three conditions. If we are given two linear equations in two variables, and if I want to solve them, there are three possible conditions. One, there is an unique solution. Unique solution means we are going to get only one value of an x, only one value of y, which will satisfy both these conditions. If I draw the graph, unique solution means only one solution, okay? Only one solution. If we draw the graph will, the two graphs, the graphs of the two equations, they will intersect, graphs will intersect at one point. The coordinates of that one point is the solution, okay? And the condition for unique solution is it can be given based on the coefficients of x and y. What will be the condition? The condition will be, you can draw the graph and check if they are consistent, they have unique solution or not, if they intersect at one point or not. But an easier way to determine if the two graphs intersect at one point, or whether they are parallel, or whether the two graphs they coincide with one another, is just by checking at the coefficients of the two equations. Also, if it is unique solution, the condition will be a1 by a2 does not equal to b1 by b2. Okay, so if I take an example, the example that we just did. Okay, how much is the coefficient of x here? It's 1. Coefficient of x here, it's 1. So here a1 is 1, a2 is how much? 1. What about y? The coefficient of y is 1. The coefficient of y is how much? It's -1 because we have a minus sign in the front. Okay. So in this case, a1 is equal to 1, a2 is equal to 1. B1 is the coefficient of y for the first equation. So we will have b1 is equal to 1. b2 is equal to -1. Divide them, a1 by a2. This is 1 by 1, which is 1. What about b1 by b2? b1 by b2 is 1 by -1, which is -1. They are not equal, right? So this condition is satisfied. If this condition is satisfied, we will have only one solution. And when we draw the graph, the two graphs will intersect at only one. Is it possible to intersect at 2 points? No, unless it's a curve. Okay, so the other solution, the other possibility of solution, the next possibility is when the two graphs are parallel. When the two graphs are parallel, it means there is no common point between the two graphs. That means there is no solution for the two equations. Okay, so this one we are going to call it as inconsistent. What about inconsistent? There are no solutions for the two equations. If I draw the graph, what will happen to the graph? The graphs of the two equations, they will be parallel. So graphs will be parallel. And what is the condition for inconsistent based on the coefficient of x and y is? We will have a1 by a2. This is equal to b1 by b2, but not equal to c1 by c2. Example can be like this: x plus y is equal to 3, x plus y is equal to 4. I've given it like previously. Look, a1 by a2 is 1 here, 1 here, 1 here, 1 here, 3 and 4 here. This is a1, b1, c1, a2, b2, c2. How much is a1 by a2? a1 by a2 is the coefficient of x and x in the two equations. So we will have 1 by 1, which is 1. What about b1 by b2? b1 by b2 is also 1 by 1, right? The coefficient of y are same. So we have the condition a1 by a2 is equal to b1 by b2. Both of them is equal to 1. What about c1 by c2? c1 by c2 is 3 by 4, which is not equal to 1, right? So if this condition is satisfied, if I draw the graph of these two equations, then we are going to get two parallel lines. They will never intersect. Okay, uh, the third possibility is if the graphs of the two equations is the same. That condition we call it as dependent. Okay, dependent means the two equations are the same. The two equations are same. What about the graphs? Graphs are, we won't say same, okay, we will say they are coincident. They are on top of the other. And the last one, what is the condition for dependent? The condition for dependent is divided by, if I divide a1 and a2, b1 and b2, and c1 and c2, they all will be same. Like this, a1 by a2, b1 by b2, c1 by c2. This is the required condition. Let's take up an example. X plus y is equal to 7. 2x plus 2y is equal to 14. If I take 2 common from all of them and cancel them out, we are going to get x plus y equal to 7. How much is a1 by a2? a1 is the coefficient of x, which is 1. So a1 by a2 will be 1 by 2, right? So a1 by a2 is 1 by 2. What about b1 by b2? b1 by b2 is also 1 by 2 because the coefficient of y here is 1. Coefficient of y here is 2. What about c1 and c2? c1 and c2, you have to divide the two constant terms on the right hand side. So we will have 7 by 14, cancel them, we get 1 by 2. It's exactly the same, right? a1 by a2, b1 by b2, c1 by b2. Half. So you need to keep in mind these three conditions. The first one, unique solution, we call it as consistent. And you have already known the condition for fulfilling consistent, if two equations are consistent or not. Then second one, we have got inconsistent, graphs are parallel. We have known the conditions also. And the third one is the dependent. Okay, you need to keep this in mind because in the board exams, in your board exam, the questions are made mostly in multiple choice types. The question will ask what is the condition for dependency of two equations in two linear equations in two variables, and or you will be given two linear equations. You have to determine whether the graphs are intersecting, parallel, dependent, that sort of thing. Okay, so if I take up two equations, and then let me take up one or two questions from your exercise, and we will check if the equations are consistent, inconsistent, or such. Okay. Okay. So first of all, I'm taking up this question. You have to check the question is check whether the equations are consistent, inconsistent. Okay, you have to check whether which of these three condition is satisfied. So first one, Roman number one, we are taking up x plus y is equal to 5. 3x minus 5y is equal to 9. You have to compare this with the equation a1x plus b1y is equal to c1. What is a1? It's the coefficient of x. What is b1? It's the coefficient of y. C1 is the constant term. Constant term that is shifted to one side or it's on the other side. Okay, if I have 5 here, 5 on the left hand side, then you have to have the 9 on the left hand side also. Unless you do that, you might be getting a wrong answer. Okay, here this is fine. 5 and 9 are on the right hand side. So how much is a1? A1 is 1. B1 is how much? B1 is 1. What about C1? C1 is 5. A1 is taken from the coefficient of x, right? What is in the front of x? B1 is taken from what is in the front of y. C1 is taken from the constant term itself. Do the same here. We have to compare this equation with a2x, b2y is equal to c2. What is a2 here? A2 is 3. And you have to be aware that since we are using plus sign here, when you take the value of a2, b2, c2, a1, b1, c1, you always have to take together along with the sign. So here a2 is this, b2 is this, c2 is this. A2 is how much? A2 is 3. B2 is equal to how much? 9. Minus 5. C2 is equal to how much? 9. When do you need to find out C1 by C2? C1 by C2, you need to find out only for the condition of inconsistent. Because for inconsistent, it is A1 by A2 equal to B1 by B2, does not equal to C1 by C2. Okay, so for inconsistency, we have the last term as C1 by C2. But if we don't have the condition for, if you don't have A1 by A2 is equal to B1 by B2, you don't have to check out C1 by C2. Okay, how much is A1 by A2? It's 1 by 3, right? B1 by B2, 1 by minus 5, which is minus 1 by 5. They are not equal. So you just can write A1 by A2 does not equal to B1 by B2. No problem. So right here, A1 by A2 does not equal to B1 by B2. Which condition is it? This is the condition for what? Consistent. So we will say here, therefore, what is consistent? These two equations right here. What is the meaning of consistent? If I draw the graph of these two, they will intersect at one point. If I find out the solution, we will get a point. The value of x and y which can satisfy these two equations is there is only one of them. Okay. Okay, let's move on to the next question. We'll take up one for inconsistent as well. I'm keeping the A1, A2, B1, B2, C1, C2. So Roman number 2, let's take up another. Roman number 2, we have got 3x minus 4y is equal to 7. 9x minus 12y is equal to 21. Okay, let's check whether this is consistent, inconsistent, or dependent. Okay. So A1 is how much? A1 is 3 here. This is A1. This is B1. This is C1. Only thing you have to note is the value of B1 you have to take along with the negative sign. So A1 is 3. B1 is how much? It's minus 4. C1 is how much? It's 7. A2, put the values also. It's 9, minus 12, and 21. Calculate the A1 by A2. This is 3 by 9. You have to cancel it whatever you can. Okay, 3 1s are 3, 3 3s are 9. So we have got 1 by 3. What about B1 by B2? We've got minus 4 divided by minus 12. Cancel the minus sign. 4 1s are 4, 4 3s are 12. Do the same thing for C1 by C2. Why we are finding out C1 by C2 is because A1 by A2, B1 by B2, they are equal. If they are equal, it could be the two remaining condition. It could be inconsistent or dependent. Okay, so check the C1 by C2 if consistent is not there, if these two are equal. So C1 by C2, we are going to have this as 7 divided by 21. Cancel it. 7 ones are 7, 7 threes are 21. We have got 1 by 3. All of them are equal, right? So what we are having is a1 by b1 is equal to, I'm sorry, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. What was this the condition for? This was the condition for dependent, right? Dependent means if you draw the graph for these two, if you draw the graph for these two, we are going to get only one graph. It may look like this or it may look like this. But we are going to get only one graph for both of them. Okay, both of them we are going to get only one graph. That's the meaning of dependent. So we will say here the two equations are dependent. Okay, one more example. This is the last one. Let's take one for inconsistency. Okay, so Roman number 3, I'm taking up this example 3 by 2x plus 5 by 3y minus 7 is equal to 0. 9x plus 30y is equal to 40. Okay, let's put the value of a1, a2, a3, a1, a2, b1, b2, c1, c2 later on. Okay, first of all, there are some changes you need to make in one of the equations so that you will be able to find out a1, a2, b1, b2, c1, c2. Look here, the difference between these two equations is in here the constant term 14 is on the right hand side. What about here? The constant term is 7, but it is not on the right hand side. This is problematic. Okay, if I take c1, then you cannot put it as minus 7. The constant term, they have to be on the same side. The x and y term, they have to be on the same side. Same thing with y. Okay, you cannot have x on the one side, y on the other side. You cannot compare these two equations like this. You cannot find out the consistency, inconsistency, or dependency of these two equations just by putting like this. Okay, you have to put the variables on one side, constants on the other side, or you can put all of them on one side. So first of all, what we are going to do is we have to change this a little bit. Also, we have to bring the 7 to the other side. So we will have 3 by 2x plus 5 by 3y is equal to 7. The other one, you don't need to change, just keep it as it is. Now you can find out a1 is equal to 3 by 2, b1 is equal to 5 by 3, c1 is equal to 7. What about a2? a2 is 9, b2 is 30, c2 is 14. Simple, right? Okay, let's just do the division a1 by a2, b1 by b2, c1 by c2. So a1 by a2, how much is it? 3 by 2, 3 by 2 by 9. This is the numerator. You have to bring the 2 down here. So we are going to get 3 by 2 into 9. 3 ones are 3, 3 3s are 9. So we have got 1 by 6. What about the other? b1 by b2. We've got 5 by 3 divided by b2 is how much? 30. Bring the 3, the denominator here again. We've got 5 divided by 30 into 3. Okay, where's the mistake? No. So you can cancel out these two, 5 and 30. So we have got 1 by 6, 1, 6. So we have finally got 1 by 18 here. Look, these two are not equal. Obviously, this is not an inconsistent equation. These two are not inconsistent. So a1 by a2, we have got 1 by 6 here. And what about b1 by b2? b1 by b2 is 1 by 18. They are not equal, right? a1 by a2 is not equal to b1 by b2. If they are not equal, you don't need to find out c1 by c2, because if a1 by a2 is not equal to b1 by b2, it will be this condition right here. Not inconsistent, not dependent. So from here, I can say a1 by a2, it is not equal to b1 by b2. Hence, what will happen? The two equations are, what are they? They are consistent. So you check up exercise 6.1. There is a whole lot of examples given there, the whole lot of questions given there for you to practice. You already know how to find out a1, b1, c1, a2, b2, c2. And during revision, I want you to understand the meaning of this consistent, unique solution, inconsistent or parallel, dependent or infinitely many solution. You have to understand what is the meaning of each of them, because We're going to use it when we solve questions graphically. Okay, we will take up different examples in order to solve two given linear equations in two variables. So with this, let's finish today's portion. The next video, I will take up how to solve. We have already done how to solve two equations with using graphical method. I will draw up the actual graph by taking up some examples from your textbook exercise. It will be very interesting. Okay. With this, we'll have to finish here. Okay. Goodbye.